All right, so here we are with chapter 16, critiquing scientific ideas. So, you do the thing, you write your research, you put it out there, and other scientists are going to evaluate your ideas and your research. That is critiquing. Now, when they actually write up the review of another scientist's work, that is called a critique. And it's going to analyze your ideas, the evidence that the scientists used to back up the ideas, the experimental method, the collection of data, and or the interpretation of data. Remember how I told you guys that all those steps are super important that your data be accurate, super important that you have proof to back up all your ideas. This is why other scientists will critique you. So let's get started with Roman numeral 1. So scientists evaluate each other's ideas. Let's make that bigger. All right. Oh, I'm pressing the wrong button again. So it says that's critiquing. All right. Now scientists can write a review of another scientist's work. We call this a critique. And basically a critique, can't even say it, analyzes a scientist's ideas, the evidence the scientist uses to back up their ideas, the experimental method the collection of data, and / or the interpretation of that data. All right, and that's it for Roman numeral 1. We'll move on to number 2. Pause here and get this all copied down. All right, so Roman numeral number 2. How to critique, I'm not typing. How to critique a scientist's ideas or research. All right, so sometimes, believe it or not, you're actually asked to critique another scientist's work. So we're going to go over the 5 important things to consider when you're critiquing another scientist's work. Guys, I can't type today. the heck? There we go. Yes.
What if you get like 11?
All right, so like I was saying, there are 5 important things to consider. Ideas or research. There are 5 important things to consider. All right, coming in at number 1, you want to find out what evidence is that scientists using to back up their ideas. It's all about the proof, guys. All right, so science has to be backed by facts and accurate information. So when you're looking at the evidence, you want to look to see what facts theories, observations, and /or experimental data, the scientist uses to prove their ideas are correct. So when you're critiquing, it's super important to point out the presence or absence of evidence. Let's just get rid of that right there. And that's it for point number 1. Pause here and copy that down, and we'll go into point number 2. All right, and what do we know about science? It is based on what? Facts. It is not based on what? Opinions. Oh my goodness gracious, what is happening here? So let's delete all of this and go into number 2. All right, we'll leave that heading up there. We're on point number 2. So you're going to look to see, does the scientist use feelings or opinions to back up their ideas? That is no bueno, guys. Cannot use that. So think of it as doing like an audit. So it's also important to point out feelings, biases, or opinions that the scientist uses to back up their ideas because why? Because these are not valid pieces of evidence. Remember, evidence has to be based on fact. It can't be based on anything that we cannot prove, and we cannot prove opinions, biases, or feelings. All right, so coming in at number 3. So you're looking at the evidence, right? You're making sure there's no opinions or anything like that. Now, you need to see that evidence that you're looking at, is it accurate? Is it valid? Because if it's not, if it's based off of bad evidence or bad data, then that invalidates the whole study. So, number 3, is the evidence or data accurate and valid? So, if a scientist uses data from an experiment as evidence, make sure the data is accurate and valid. And how are you going to do that? Well, you're going to read through the experimental method that they used. Then, you're going to look for sources of error, which we've talked about before, or flawed interpretations of data. So remember, sources of error are things like small sample size, not that many trials, basing things on opinions, anything like that is a red flag, no bueno. You're going to write that in your critique. All right, that's number 3. Pause here, copy this down, and we'll continue with number 4. All right, so just like when we are presenting something, when we are engaging in scientific debate, we have to, even in a critique, even in writing, you have to use respectful language when critiquing someone's work. Okay, so when you're critiquing, it's okay to point out the flaws in the research. In fact, that's your job. But it is not okay to be disrespectful when critiquing their work. You'd have to use language like, I view this differently because. I do not agree with this because. I think the scientists didn't consider. Do not terms such as bad. Do not use anything like bad, stupid, ridiculous. Remember, this is constructive criticism, not just mean criticism. You're not trying to offend anyone. You're trying to help out the scientific community. So, it's okay to point out flaws in a scientist's ideas or research. But it is not okay to be disrespectful when critiquing their work. So like I said, we're going to use language like, where'd my cursor go? There you go. So use language like, I view this differently because ... And be prepared to back all these statements with actual evidence. You can't just say this. I do not agree with this because, notice how there's always that because there. You have to state why you do not agree. Or, I think the scientist did not consider.
What are you doing? No, your mom.
Okay, you are not going to use terms like where's my cursor? Oh geez. Do not use terms such as bad, stupid, or ridiculous. Remember that a criticism is meant to provide effective and constructive feedback. All right, and there's just a little bit more after that. So pause to make sure you have the first couple of sentences, and then we will move down. So I'm just going to delete this part up here. Oops, too much. So it is not, so it's meant to provide constructive and effective criticism. It is not meant to offend or insult the scientist. All right, and that wraps up point number 4. Go ahead and make sure you have that all copied down, and then we'll move on to point number 5, our last point on how to critique a scientist's ideas or research. All right, and lastly, number 5, after you're done ripping apart someone else's paper and telling them everything they did wrong, you should probably say something nice about their research. Don't completely leave them on the floor. So you're going to point out positive aspects of the research. A critique should not be entirely negative. That's kind of soul crushing, and we don't want to do that. So it shouldn't just be negative. You should also draw attention to things that were done well and thought out correctly. And just, to be even more specific, you want to be sure to highlight at least 3 positive aspects of the investigation or scientific idea. All right, and that wraps up point number 5 and Roman numeral 2. So pause here, make sure you have this copied down, and we will go on to our third and final Roman numeral. So number 3 is how to receive criticism. So we talked about how to give criticism, but don't give it, don't dish it if you can't take it. So now we're going to talk about how to receive the criticism about your scientific ideas or research. So just like you are critiquing other scientists' work, other scientists are going to critique your work. And here is what to do when they do. So as I said, there are times when you will receive criticism about your ideas. Or research. There are 5 important things you should consider when receiving criticism. All right, so the first thing we're going to do, probably a little bit obvious, but we're going to listen to the criticism. All right, I know you've spent a ton of time on your research and your ideas and the experiment and the investigation, and a lot went into it. And the first thing you're going to do when someone comes at you critiquing your stuff, you're going to want to defend it. But don't. Wait and listen to everything they have to say first. So point number 1, listen to the criticism. So the first thing most of us want to do when receiving criticism is to defend ourselves. Why? Because it can make us feel anxious. and defensive. I know I get super defensive when anyone criticizes me. It's something I need to work on as a scientist and as a person. So even though it makes us feel that way, it is important we set that aside. So that you can truly listen. To the criticism. Where's my cursor? Not there. Okay, there you go. So if you truly listen, to the criticism, you can use it to improve your ability. To think and behave like a real scientist. Oh, what the heck just happened? I'm just going to abbreviate that. SCI, but know that that means scientist. All right, that's it for point number 1. Pause here, get all this copied, and we'll go on to point number 2. All right, so after you've listened to the criticism, you're going to want to ask questions. If you want to grow from this, you need to ask questions and really understand where the critic was coming from when they wrote that about you. If you can't talk to the critic, you can talk to a coworker or a teacher, and they can go over the critique with you, and then they might be able to give some insight as to where the critic was coming from, or the critique. So number 2. So if you want to grow from criticism, ask questions. If you have the opportunity to speak with the actual critic, ask the person questions about the criticism. Oops. Any day now. No, okay. So if you don't understand why they're critiquing you the way that they are, you can ask them, can you explain to me why you wrote this? And if you can't do that, ask someone else. So their other perspective can maybe answer where that critique was coming from. Oh, we're the critics, sorry. All right, that's it for number 2. Go ahead and pause here and we'll go on to number 3. So you want to self-assess your ideas and research like an outsider. Meaning, don't take it personal. Try to step outside yourself and see if you can see why the critic made that feedback. So take time to really self-assess yourself. Can you understand where the critic was coming from? Does it make sense why the critic provided you the feedback that they did? All right, and just like you were required to give some positive when you wrote your critique, when you're being critiqued, try to focus on the positive. Because remember, we're not looking to put each other down. So a respectful critic is not looking to put you down or hurt your feelings. Look for and focus on the positive things that the critic pointed out. All right, pause here, get this copied, and we'll go on to our 5th and final point about receiving criticism. All right, and lastly, and perhaps most importantly, learn from the criticism. And doing this helps us correct any mistakes that we may have made in the future. So the best way to make use of criticism, because remember, we're not doing it for our health, there's actually a purpose, is to learn from it. Understand the mistakes you made and correct them in the future. Science is all about improving ourselves as well, guys. All right, and that wraps up chapter 16, our final chapter. We'll go ahead and do our activity, and we'll be done with this whole scientific method section. Yay!